Hello, my name is Bhargav Sompro, and I was given this assignment as order execution and management system on Deribit test API. So let's start with the code first, explaining the code first, and then we'll see the demonstration. So starting with the first configuration file, it's basically a header file where the namespace config has been defined with basic variables that we are going to use throughout the project. So the variables are including the base URLs, the API key and secret that I get from the deribit.com, and endpoints are declared here for order book, for placing order, selling order, cancelling order, modifying order, etc. Next are these models, basic models like order book history entry and the order book. So order book is basically contains two vectors. First one is bids and second is ask. So bid is basically comprises of all the uh, buy orders by different traders for this particular instrument that we'll try to fetch in the future. So it has price and the quantity. Also the ask vector has price and quantity, and they are like sell orders from different traders. So bids are the buy orders and ask are the sell orders. The next is orders.h. Here we are declaring a struct of order, basically including all the arguments that we needed, like the ID, symbol, uh, the quantity, price, trigger, the type, market, limit, stop market, etc. The buy or sell, where the order is for buying or selling, the trigger price, and then defining the constructor. The next header file is the position.h, basically defining the structure position. This will basically be used to get idea about how much we are holding the particular instrument, what is the current quantity that we are holding, the name of the symbol, and its price, the entry price, exit price, or the average price. So now let's start with the Deribit API, the main API header file. Here we will declare the Deribit API class and its methods. So starting with including all the models and configuration header files, and we're declaring class of Deribit API and some private members like send request, which we will use to send HTTP request to this particular endpoint with some payloads, and then authenticate method for authenticating ourselves with the client ID and client secret to get the access token or auth token that will be stored in the public attribute auth token, the constructor, and methods like place order, cancel order, modify order, the get order book, the get positions, and get open orders. Now let's start understanding the actual implementation part of the Deribit API class. Starting with including all the headers, the configuration headers, curl.h, because we are using leap curl for making HTTP request. Then json.hup, because of its use case for parsing the JSON that we get from the response and figuring out what results that we want. Then istring for standard input output, and simple string for string operations. Starting with the basic commands for using JSON. Okay. So this is the right callback function. We'll come to this again. Next is Deribit API constructor. We are in the constructor. We are basically starting the curl global init. So initializing a curl object globally. The next is authenticate method. Authenticate method, our interest is to send the client ID and client secret and get the access token. So what we are doing here is that we are declaring a curl cURL operational handler. This is basic handler. Then pointer to this is the pointer to the session that has been created, which will handle all the cURL operations. Then cURL code result, this is enum type of variable, which basically store whether the response coming from cURL operation is okay or whether it contains some error. Then read buffer, where the response will be stored. This is the authentication URL where the request will be directed. Then we're starting with the cURL easy init, initializing the cURL operation. Then if it is working fine, then we'll populate it uh, with the URL as auth URL dot cstr. Cstr because we are converting the string to a constant character array, because the libcurl supports like C styling character array. Therefore, string need to be converted to constant character array. And next, we need to write the operation write function, which is the callback function, kind of a callback function that we need to declare once the request has been sent to server and we receive a response. Then a callback function is called on that response. So here it is the callback function. What it basically does is that it receives the content, it populates the buffer that we wanted the response to be in it. Here we can see that user p is a pointer, it's basically string pointer, which is being populated with the content that we have received in the response. And the callback function basically returns the size of the basically response, the number of bytes that we received in the response. The write data read buffer. So this read buffer will be used in the callback function to populate the response. SSL verifier peer and SSL verifier host are being disabled for this particular project, because there were certain error I was facing, and the best solution on the internet was to disable them temporarily. It works for me, so here it is. And next is the header file. So header file, we need to include the content type as application JSON, because all sort of client and server communication will be a kind of JSON exchange. So this is being added to the header, and this will be populated in the cURL operation HTTP header. So this header will be used in the cURL operation. Now the curl easy perform, here we are basically performing the actual request operation, and the response, or we can say whether the cURL response is stored in res. So basically it checks whether it's okay or it contains error. Or if it contains error, then we'll just clean up the cURL and return false. Otherwise, we'll clean up the header files, freeing all the memory, cleaning up the cURL operations, and then parsing the read buffer to a JSON object, and then checking if it contains error or not. Otherwise, the result and access token from this JSON object will be stored in the auth token. So this is here we are basically using try and catch as a handle exception, because we do not want our app to crash if we receive error in JSON response. Next is okay. So the next is a place order. So place order method is basically used to place buy or selling order for a particular instrument with the price and the order type. So here we are using an endpoint as config namespace base URL. Then whether if it's buy order, then we'll use buy endpoint, place order endpoint, otherwise sell order endpoint. Similarly for payload, the basic structure is being followed using uh, the structure that was given on the doc of the deribit.com. So this is how it was here, because it was supporting JSON RPC, so its version is there. Then ID, the unique ID for each request is required to for the cURL to understand that which response is coming from for which request. Since we are using synchronous calls, so I'm just using one and not different unique IDs for different requests, because it's a synchronous call, so it won't be an issue for the current program to understand that the response is coming from for the single request that was sent. The next is the method. If it's buy, then the root will be private buy, otherwise it's private sell. Then the parameters that are required are the instrument name, which we get from order symbol, the amount, quantity, the type, whether it's market, limit, stop limit, etc., and what is the price that we wanted to work on. Then there is conditional statement that if the order type is stop limit, stop market, trailing, take limit or take market. Then two more of parameters, name, trigger price, and trigger are also required in the payload of the send price request. Yeah, so here the payload is being complete, and then we are calling send request function with this endpoint and the payload. So here I have defined the send request at the end. Yeah, the send request is basically taking two arguments, the endpoint and the payload. It's again using the similar sort of stuff, URL, response buffer, initializing things, and then checking whether the auth token is there or not. If it's not populated, then authentication is required, because placing order and selling orders are private routes which requires authentication. So we'll first call the authentication method to get access token, and then after receiving auth token, we'll update our header and then populate the header in the cURL set operations. Again, similar sort of code, and then we'll perform the response as the cURL HTTP request, and then the cleanup and then the read buffer would be sent back to the calling function. So here in the place order, we'll receive the read buffer, whatever the response that we get from the request. Yeah, so the response will be a read buffer string, and then we'll parse it to the JSON object and check if it contains error. Otherwise, we'll say the order was successful for this order ID. Similar for the cancel order, we just require order ID, and everything else was just similar. Configuring the endpoints, defining the payload, then calling the send request method, receiving the request and parsing it to the JSON object, and checking if it contains error. Otherwise, it's okay. Similar for modifying error, there were three parameters for this: the order ID, the amount, and the price. The only two quantities that actually change for any order ID, although there were certain advanced options on the side, but I preferred for simplicity just two options here: the quantity and the price that has been changed. Again, then calling send request with this endpoint and new payload, getting the response and checking if it's error or not. Get out of book. Get out of book function is basically help us to understand that for a particular instrument, what are the current top bits by all the players or all the traders, and what are the current selling orders. So basically, for a particular instrument, it returns top 5 or 10 according to the depth by default, which is 5. So it returns basically top 5 buy orders and top 5 sell orders by different players in the market. Again, using curl for the similar set of operations, initializing and then populating the header, checking if it's authenticated or not, then again populating the set operation with the endpoint, header, then callback functions, the read buffer, verifier, disabling, and then performing the operation, getting the response, and if it does not contain error, then we'll populate the order book vector with the response that we receive with build and ask. Next, we clean up, curl, almost free all the headers similar, and return the order book. So next method is the get open orders. So get open orders is basically helps to returns basically all the orders that are not yet fulfilled, the orders that are made by us but are still open on the market. The orders like limit, stop limit, etc. This kind of orders which are not executed immediately would be the part of the get open orders. Yeah, we are declaring the endpoints, defining the payload which is required. It does not require any parameter. So just get all the open orders which are coming into the response, and we are just printing out all the open orders. The get position basically returns the amount of instrument that we are holding at the average price. So let's say we have BTC perpetual and we wanted to check how much quantity are we currently holding. So the get position basically helps to do that. So again, similar set of operations, declaring its endpoint and then calling curl, initialization cURL, and then appending header, authentication, again populating the cURL easy operations, then performing it, getting the response, parsing, checking for errors. If not, then we are populating the position object and then returning the position object to be shown on the standard output. So this is a standard request that we have already discussed. This was a Deribit API CPP, and the main CPP file is here. So in a main cpp.file, what we are doing is just creating an object of Deribit API and then looping while getting orders from getting options for the user what they wanted to do, then using a switch case operation for calling according to the option chosen by user different functions. For example, see place order, and so for every option, every function, we are passing the Deribit API object. Yeah, so for every function like place order, all the required input are being taken from the user, and then an object is initialized, order object is initialized, and then a API method is being called with that object. Similar for cancel order, the order ID is being taken with the user, and then API cancel order method is being called with order ID as an argument, and whether it was successful or not, it was shown on the standard output. Similar for modify order and get order book also. We're converting. Okay, so get order book also is printing out all the outputs, everything to the output, view position as well. Okay, so this is it with the code. Now let's see the demonstration part, the code, how the code is working. Okay, so call as let's run the executable file. So here we get all the options, or the user get all the options of operations that he can perform. Let's say first we can see what are the open orders that we have currently. Yeah. So these are the list of the open orders that we have currently in the market, which basically giving all the details like order ID, the instrument name, the price, the quantity that we are wanted to sell or buy, the status, its current status, its type, whether it's limit market, stop market, etc., and its direction, whether it's for buying or selling. Now let's try to add another order. Say I wanted to place another order. It's a buying order, and it would be picture. Quantity would be like 400. Type I want it to be limit, so it should be 65. Yeah, so order was placed successfully for order ID. Now let's try to see for our open orders. Since limit is not executed immediately, so it will be shown in our open orders. So here we can see that 2933, 6500 was our price and 400 was our quantity. Now let's try to modify this one. For this we need the order ID. Let's go to the option 3, modify order, and then order ID. New price I want it to be 68,000 and quantity would be 500. Now let's check. Yeah, the order was modified 68,000. With quantity 500. Now let's try to cancel this order. I would say cancel this order too, and this order ID. Yeah, the order was cancelled. Let's again see our open orders and should be part of it. And yeah, here we can see that it's no longer the part of our open orders. So this was about open orders. Let's try to go for market order type. First, let's see positioning. I wanted to know how much BTC perpetual am I holding right now. So it's 1200, sorry, 2100 size, and average price is 70,000. So yeah, let's try to place some order. Let's buy some BTC perpetual. Quantity, let's say 500. I wanted to buy 500 amount, and type market. So it would buy immediately. It's asking for price, but yeah, it was not needed. Yeah, the order was played successful because market order type are generally executed at the market price. Okay, let's again try to see the positioning of BTC per picture. Should have it changed? Yeah. So the size is now 2600. So we have buy 500 more BTC per picture. So this was about my project. Everything is working, and thanks for the opportunity. I would greatly appreciate if you consider me discussing more about this project and get me a chance to work with you guys. Thank you.